Okay, I'm going to move on to exercise 7C, which is uh, understanding the geometrical properties of quadrilaterals and a few other polygons. So, the first thing we need to know is what is our definition? And definitions in geometry are vital and they need to be complete yet succinct. That means they need to include everything that you require as well as being succinct and not having more stuff that you don't need. So, the way in which we word our definitions is very, very important. So, the first thing we need is our definition of what a polygon is. So, here we get a lovely definition: closed, two dimensional shapes with straight sides are called polygons. And that's our first definition over here. A polygon is a closed two dimensional shape with straight sides, and that is where you leave it. However, we want to write in some of the properties. Now, what are the properties of a polygon? Well, all polygons are different. Like you can have triangle, quadrilaterals, pentagons, hexagons, heptaseptagons, octagons, nonagons, decagons, and you can keep going. And all of those just represent the different sizes. So all the properties will be different, except for one. There is one property that all polygons have, and that is that the exterior, and you need to be writing these notes, exterior angle sum is always 360. Right, so let's have a look. So there are all those polygons, and they all have different things. We're going to talk about this thing in a minute, but let's move on from there and let's have a look at this exterior. What is that exterior angle? It means this, that these angles here, this one, this one, this one, this one, this one, must add up to 360. And that happens in every polygon. The exterior angles all add up to 360. Now, there's this other word, regular. That just means when you say it's a regular hexagon, it means that all the side lengths are equal, and as a consequence, all the interior angles are equal as well. All right, this main thing is to look at our first type, which is quadrilaterals. You've already done triangles, but now we're going to look at quadrilaterals. So we need a definition of a quadrilateral. Now, a quadrilateral, we need to be specific, and I've left this out on purpose because we don't want to have to repeat, like, say it's a four-sided 2D shape with straights. So we're just going to say a quadrilateral is a polygon. And all of a sudden, we don't have to say closed two-dimensional shape because up here, we already defined what a polygon is. So we don't have to go. And then a bonus is we don't have to write any of the properties. We don't have to write this property again because we've already said it's a polygon. So it inherits that property. We know because polygon is in the definition. So we know all polygons have an exterior angle sum of 360, so we don't have to write it again. So that's what I mean by being clear and succinct. So a quadrilateral is just any polygon with four sides. So you can draw any four-sided shape. There you go, there's a quadrilateral. I'm not going to use that because I'm going to draw just, that's even worse. I wanted something nice and, anyway, quadrilateral, four sides. What are the properties though? Well, the properties are the, the interior angle sum is 360. And what does that mean? It just means that these angles, we'll call it A, B, C, and D. So A plus B plus C plus D equals 360. That is the only property of a quadrilateral that we have, because all different quadrilaterals. Where did that come from? I'm going to do this really quickly. So the angle sum of a triangle is 360. Now I'm going to prove this later on. I'm not going to prove it now, but A plus B plus C, 360 is 180. Angle sum of a triangle is 180. And I can prove that, and we'll do that later when we do some proofs. All right, so we move on to the geometry proof. But for now, let's just go with the fact that that is true. Well, every polygon where you increase another side, so let's make a four-sided one. There's a four-sided one. I can break that up into two triangles. And this triangle is 180, and this triangle is 180. So 180 plus 180, 360. What if I had a pentagon? And it doesn't have to be regular. Make that a bit bigger. There's a pentagon, and I can bust that pentagon into 1, 2, 3 triangles. So it's going to be 3 times 180. All right, so another 180 plus 360 is 460 is 540. So this will be 540 degrees, the angles inside. And I can keep going. I can draw a hexagon. And if I bust that up, 1 triangle, 2 triangles, 3 triangles, 1, 2, 3, 4 triangles. And then all of a sudden you're going, it's just 2 less of the sides, and that'll tell me how many triangles. And that is what this formula is. It's 180, which is 1 triangle, times 2 less than the sides of the polygon. And that's where that S equals 180 n minus 2. So now we've got what a polygon is, a good definition, a quadrilateral. I've drawn a Venn diagram here. I'm going to fill that in as we go. Because as we go along here, so the first type of quadrilateral, and we're going to go in order of least complex down to the most complex. Now, the only other one that is a bit dodge is this kite here. It sort of doesn't fit in there. We'll do it at the end. So the first thing we're going to do is we're going to define a trapezium. So a trapezium is a quadrilateral with at least one pair of parallel sides. So that's my first one, a trapezium. And it sits there. Now, I don't need to write any of the properties from up here because it inherits them. The exterior angle sum of a trapezium, it's a polygon. Why is it a polygon? Because it's a quadrilateral. Okay. So its exterior angle sum is 360. And because it's a quadrilateral, it inherits the interior angle sum. So I don't have to write any other properties because I've got the word quadrilateral in there, which encompasses the angle sum, interior, and because the quadrilateral definition has polygon in it, it inherits the exterior angle sum. So I don't need to write anymore. But I do need to draw a diagram. Now, you should be using a ruler for this. I'm trying to do this on freehand. And there's my trapezium. Now, it's easier. Okay, so let's put in the definition. It's a quadrilateral, there you go, it's four-sided, with one pair of parallel sides. So indicate those sides are parallel. Now, because they're parallel, I get this angle, and this angle. Well, they're co-interior. All right? And the same with this angle and this angle. So my property is that in a trapezium, uh, we have co-interior angles. And there we go. So there's our trapezium. Well, what comes next? Well, a parallelogram comes next. Now, look what I've done. I've used trapezium in my definition. And because I've done that, because I've used trapezium in my definition, I don't need to write all the other properties. It inherits exterior angle sum, interior angle sum, co-interior angles, so I don't have to write those properties again. It's a good idea to draw it, however. And because I'm going to demonstrate the properties, I'm going to draw two. So here's my parallelogram, and I'm going to have another one. What's the properties? Parallelogram with opposite sides parallel. So that and that are parallel, and that are parallel. Got to indicate that. Any properties I do, I will do in a different colour. So the first property, well, we know that this angle and this angle must add up to 180. But we also know that this angle and this angle must add up to 180 because they're co-interior from the other side. So that means this angle must be the same as that angle, and that angle must be the same as the one up there, and that is our first one. Opposite angles are equal. So there's our first one. Also, this side and this side must be the same length because they're the same distance apart, and this side and this side must be the same length because they're the same distance apart. So opposite angles are equal, opposite sides are equal. Righto. Now we talk about diagonals. And the diagonals of a rhombus do something, of a parallelogram do something. They're not the same length, all right? This one is going to be shorter than the other one, but they do bisect each other into equal parts. So the diagonals bisect each other. And that's it. They're all the properties of a parallelogram. Now, let's just double check. Let's have a look down here, and you can see they've got their parallelogram there. They haven't shown all the different angles in there, but they've shown that the diagonals bisect each other, that opposite sides are equal. I really wish they had done that opposite angles are equal as well. Now, the next two come together. They are a rectangle and a rhombus. And you can see, so I better put in parallelogram here. And you can see if they are in a circle that they inherit all those properties. Well, let me grab it there. Right. So, because the parallelogram is in the trapezium circle, well, it inherits all the properties of that. And because the rectangle is wholly within the parallelogram circle, it inherits all the properties of the parallelogram. And because the rhombus is in the parallelogram circle, it inherits all the properties of the parallelogram. In fact, and this is a really cluey bit, if I said draw a quadrilateral and you drew a trapezium, would you be right? Yes, you would. A trapezium is a quadrilateral. And if I said draw a quadrilateral and you drew a rectangle, would you be right? Yes, a rectangle is a quadrilateral. But if I said draw me a trapezium and you drew a parallelogram, would you be right? Yes, you would, because a parallelogram is a trapezium. It's just a trapezium with some extra things. If I said draw a trapezium and you drew a rectangle, would you be right? Yes, because a rectangle is a parallelogram, which is a trapezium, and the same for a rhombus. And when we get to a square is everything. Let's put it in now. So I'm going to put the square in because the square is everything. The square sits inside every circle. So let's go down here. A rectangle is a parallelogram with a right angle. So because we've used parallelogram in the definition, I don't need to write those three properties. It inherits them. So I'm going to go to this for my rectangle because it'll come out. Oh, I should have done it for one. There's my rectangle. Do I need more than one? I don't think so because I don't have to write all the other properties. But anyway, what extra properties does it have? Well, let's see. A rectangle, and I'm just going back to some notes I've written over here. A rectangle is the only other properties we have is that the diagonals are equal. So, because it's not on a slice. And, oh, sorry, I'm not going to do that. Because that is 90. A rectangle is a parallelogram with a right angle. Oh, but why don't you have to do all the others? Because opposite angles are equal, so that's going to be 90. These two angles add up to 180, so that's going to be 90, and that's going to be 90. Only state in your definition the bare minimum. You don't need to state everything. And because these are equal now, well, that and that and that and that are all equal. So the extra thing for a rectangle is that the diagonals bisect each. The diagonals are equal. Because you used parallelogram in the definition, you do not need to write all those three above. You already get them. The rhombus. Well, the rhombus is a parallelogram where all the sides are equal. So what do we get here? Now you note that they're both parallelograms, but they're not each other. So what else do we get with this? All the sides are equal, so we'll put that in. So that and that and that and that are equal. The diagonals are not equal, but they do bisect each other. So that one and that one are going to be the same, and that one and that one are going to be the same. So, but there's an added bonus. They bisect each other at 90. So the properties, it has all the properties of a normal parallelogram, but it also has a one that diagonals bisect each other at 90 degrees. Now, if we go back up here to our Venn diagram, we'll see that a rhombus is a parallelogram, but a rhombus is not a rectangle. It doesn't sit wholly in the rectangle. It doesn't have, as its definition, 90 degrees. The same way, a rectangle does not sit in the rhombus square. So if I said draw a rhombus and you drew a rectangle, you would be wrong. If I said draw a rectangle and you drew a rhombus, you would be wrong. Because those two things do not sit inside the rectangle or the rhombus circle, or ellipse in this case. So now we get to our last one. Well, let's just double check. Let's have a look at the rhombus. And you can see it's got the diagonals bisecting each other at 90 degrees. Well, let's do a square. Well, we've got two definitions we can use for a square, because look up here. The square sits wholly in the rectangle and wholly in the rhombus. So you could use either definition. So we could say a square is a rhombus with a right angle. Well, let's get that baby drawn. So here's my square. It's a rhombus with a right angle. So that, and that's 90. Or it's a rectangle with all sides equal. Oh, so all those things are true as well. Well, what extra properties does it have? Well, it has all the properties of a rhombus, all the properties of a rectangle, and all the properties of a parallelogram, and all the properties of a trapezium, and all the properties of a quadrilateral, and all the properties of a polygon. It has them all. A square has everything. So the other properties are that the diagonals are, well, we don't need to write any. They're all above. It has all the properties of all the quadrilaterals because it's every single quadrilateral. It sits inside everyone's circle. Now, it does have this other thing though, because the diagonals are equal and these things are equal, and that's 90, and that's isosceles, well, that's going to be 45 degrees because these two angles are base angles of isosceles triangles, and they must be the same, and there's only 90 degrees left, and if they're both the same, a half of 90 is 45. And because this angle is 90, well, that means that's going to be 45. So they're all going to be 45 degrees, all those little angles in there. Finally, what we need to do, we need to have our formulas for area. So the area equals, in a trapezium, a half times h bracket a plus b, where a and b are the parallel sides. What about a parallelogram? Well, the area equals base times height, where height is the perpendicular height. What about a rectangle? Area is base times height. where height is perpendicular height? What about a rhombus, where area equals a half times x and y? Can't use, we're going to use a capital X, where x and y are the diagonals. And a square, well, the area of a square, area equals any of the above formulas. You can use any of those formulas. You can use base times height, half times the diagonals, half the height times a plus b. You can use any of them because a square is all of those shapes. All right. Now, I've asked that you do the following questions. Just getting it up. So, make sure you got good notes and have a go at 2, 5, 6, and 7. So let's have a look at what they're asking. Question 2. Use that formula. I'm going to do one, you do the others. So I'll take the octagon. So the octagon, angle sum, 2B. Interior, angle sum equals, well, an octagon's 8, so 8 minus 2 times 180, 6 times 180, go to your calculator, 1080 degrees. The angle sum, the interior angle sum. You can do questions A and C. Let's go down here to question 5. Find the value of the pronumerals. Here, they're making you use the fact that the angle sum of a quadrilateral is 360. So let's do B. So here is 5B. Well, that x is going to equal 360 minus all the rest. So 360 minus 36 minus 75 minus, what's that other angle? It's 90 degrees. It's a right angle. And again, calculator, 360 minus 36 minus 75 minus 90, 159. This one will be a little challenging for you because that is a non-convex, I think. Is that the word we use? Non-convex? Look up here. Non-convex, all right? Have all their interior, a non-convex has at least one interior angle greater than 180. So will it have the same? Well, yes, it will. You just use the same rule. Question 6, find the values of the pronumeral. Now we're starting to use our properties. So I'll do a couple here. And when we go to, I'm not really worried about the first two, they're kites. But because they're kites, these two angles are the same. And the same here, these two angles are the same. So that's going to be 95. And then you just go 360 minus those three angles to get that one. This one, you're going to go 360 minus that angle, and then divide it by 2 to split it up between these two. Let's have a look at C, D, E, and F. They're all using the co-interior angle rule because they're all parallel. So I'll just do C. So C, you don't even need to know the properties of these shapes, but C, B equals, because they're co-interior, 180 minus 126, because co-interior angles on parallel lines are supplementary. Do they ask for a reason? You could say because of the property of a trapezium, just tells me to find them. 180 minus 126, that's 54 degrees. Okay, question 7. Now, here you have to find the angle sum and then just do the subtraction. This is very important because there was a question in the HSC. So I'm going to do questions E, G and H. And you can do the rest. So here we go, 7E. Well, this is a regular polygon. It's a regular because all the sides are equal in E. And how many sides does it have? 5. So the interior angle sum, interior is going to equal 5 minus 2 times 180, which is going to give me 3 times 180. $540. Now, because it's regular, each angle must be the same. Therefore, B equals 540, and there are 5 angles, so divide by 5. 108. Each of those angles is 108. Well, A, that's on a straight line, equals 180 minus 108, because it's on a straight line. Look, there's a straight line, which is 72 degrees. If I then go to G, again, it's how many sides has it got? 6, it's a hexagon. So the interior angle sum equals 6 minus 2 times 180, which is 4 times 180. $720. And again, each angle is going to be the same. So B equals 720 divided by 6. 120. Now this time, these angles, this angle here does not add up to 180. It's all the way around. They'd need to add up to 360. So A equals 360 minus 120 equals 240 degrees. Now I've done E and G. I was going to do H, but I reckon you can do H on your own and have a crack at I. Then I want you to do 10. Now 10 might take you some thinking, but you just need to work your way through it. I'll do one of them. I'll do 10D. What have we got? Well, we know that those two sides are parallel. So x plus 71 equals 180 minus 72. Why? Well, they're parallel lines, and there's the C. So x plus 72, well, 180 minus 72 is 108. Take that 72 away, and I'll get 36. Is that right? I'm just going to check. 108 minus 72. 36. The other ones are going to be similar. In here, little things like working this angle out because they've got to add up to 180. That's got to add up to 360. These two, or all this angle, come on, give me the color I need. This angle, this angle, this angle, and this angle must add up to 360. because they're interior angles of a quadrilateral. These two angles are the same. Therefore, you can go 360 minus whatever this angle is, minus what this angle is, divided by 2, get these two. Hence, get that by subtracting that from 360. Here, in this one, they've shown you that this is an isosceles triangle. How do you know? It's got the markings on it. So this has to be 70 degrees because the base angles of isosceles triangle, oh sorry, not 70. These two angles here, that's 70 there, represents all of this angle. So if I've got this angle and this angle being the same, and there's only 80 degrees left, well, that has to be 40, and that has to be 40, which means that has to be 30, even though I don't need to know that. And then I use the angle sum of the quadrilateral to work out that. So just have a go at those. If you have any problems, send me an email and I will make a quick video to explain how to do those. So 2, 5, 6, 7, and 10. But please, can you make sure that you have some very good notes about quadrilaterals?